Well, it's been a great day so far, but we're not done. We've got a few more talks before we get into more of an open discussion. But I want to introduce James Whelan from Cal Poly Humboldt, my also previously differently named alma mater.
Yes.
So he's going to give us some Finding Dory references or something like that with his title. Looking forward to the talk. James, take it away.
Thank you.
Put that on if you want.
Got it. Minimize these out of the way so we can see some pretty pictures of the Upper Basin. So, howdy everybody, my name is James Whelan. This is my first KBMP meeting, so I'm very happy to be here and was incredibly blown away at a lot of the work everyone's doing. So I am a master's student down at Cal Poly Humboldt, and today I'm going to be speaking a little bit on some of my thesis work. Title of my presentation is Just Keep Swimming, Upper Klamath Basin Juvenile Chinook Survival. There we go. So everybody in this room seems fairly familiar with the 4 dams that are coming out. So I won't get into a big history lesson about those, but for me personally, I grew up in the Rogue Valley outside of Ashland. So I've been hearing about the dam removals for the past 20 years or so. When I was a kid, me and my friends used to always make the jokes with the reservoirs. Oh, you don't go swim in the reservoirs in the summer because they'll melt your skin, in reference to all the algae blooms and whatnot. But being able to become a part of this project in an area in my backyard was an incredible opportunity for me. But even as a kid, there was always kind of the elephant in the room that I didn't even really know existed until later on in life. And those were the flow control dams up in the Upper Basin, such as the Link River Dam and the Keno Dam. The Link River Dam was created in 1921 to allow for control of water release from Upper Klamath Lake. And the Keno Dam was built in 1965, creating this center reach here, kind of referred to as the Keno Impoundment or the Keno Reservoir, which flows through very flat lowland, that it's a wide stretch of river, low flowing, just kind of meanders along before it enters into more of a gorged region by Keno, the town of Keno, below Keno Dam, where the water really picks up and starts to flow through a much more narrow kind of mountainous section. So my project and project goals were to estimate survival of juvenile salmon outmigration, detect if there are any effects of the dam on survival of these juveniles, and then identify regions or diversions affecting the survival. So to do that, we used radio telemetry and radio tags to track these fish. These juvenile Chinook were held at the Klamath Fish Hatchery until they were 1-year-old smolts. We then surgically implanted radio tags into their body cavities. You might be able to see the little metal tail sticking out of this guy right here. That is the antenna of the tag sticking out of the body cavity. These tags have an average tag life of about 15 weeks with a minimum guaranteed of 12 weeks. So we kind of designed our time scale around that minimum time frame, also to hopefully negate any false mortalities of just a tag dying, but the fish still being alive in the system. So we were aiming more towards that kind of minimum time frame. We also decided to use 3 release locations in hopes of having detections throughout the entire study reach. If there were issues in the upper section of the reach, we didn't want to release fish up there and then them never reach other areas of importance that we had questions about. So to track these fish, I had 7 stationary sites set up in that Upper Basin area, spanning from the outlet of Upper Klamath Lake above the Link River Dam, all the way down to the top of JC Boyle Reservoir, specifically at the mouth of Spencer Creek, with Keno Dam being here. This section of river spans about 35 river kilometers. And I use stationary sites, which look like this. You have a radio telemetry receiver inside this job box, wired to 2 deep sink marine batteries, allowing the receiver to run 24 hours a day, 7 days a week. I would go up and do weekly battery swaps and data downloads just to make sure that the receiver never stopped recording data. And this study was in the spring of 2022. This was my first field season last year. And the study ran from April 12th, which was the release date of my fish, to June 29th, which was the date I removed sites out of the field. So along with stationary sites, we also did mobile tracking through the stretch of river between Keno Dam to Link River, which can be accessed by boat through the entire stretch. For this presentation, I kind of split the river sections up for visual simplicity. Instead of just giving you a bunch of GPS points, I can say, oh, it was located in this section of the river, which kind of simplifies it for my own brain as well. The mobile tracking really helped fill in gaps of detections between the stations, especially for ourselves. Say a fish was detected at one station, missed a station, picked up at another station. If we had mobile tracking of that fish within that reach, we can kind of fill in the time period of when that fish was moving through there. I have a couple examples, such as CH-146, who was released above Link River Dam on 4/12. Again, that was the original release date. I probably should have put that up there as well. I apologize. On 4/15, it was located at Highway 97, which is in this stretch here. 4/21 was located at South Gore Island here. 4/26 was located in the Keno stretch here. So that's very cool to see an actual kind of live track of individual fish. Another example, kind of on the opposite end, would be CH-135, who was released above Link River Dam as well, but then for about a month was just found in Lake Yreka over and over again, which is this stretch here. And if I didn't have mobile tracking, we wouldn't have known what happened to that fish. He would have just passed by a receiver and then disappeared into the void. But thanks to mobile tracking, we know that fish was in Lake Yreka. And then later on, that fish was actually detected by stationary receivers in the middle of May, much farther down. So if we didn't have mobile tracking, that fish would have just kind of been in the ether somewhere and then showed up out of nowhere. So with all that data, I start building capture histories, which some of you may be familiar with. I filtered all my data in Microsoft Access and Microsoft Excel using this criteria on the right. I modified it a bit for my own personal use, such as the number of signals being greater than 1. For my personal project, I use it had to be 3 or more signals to be considered a true detection. We tried to limit as many, or I tried to remove all false positives as I could to not skew any survival estimates. As well as in this project, they use a signal strength greater than 50. For me, each individual site, I had to create a signal strength filter unique to that one individually based on how much noise the station was getting, how much interference that station was getting. The signal strengths of interference could vary widely. So once it's all filtered, you get to look at this pretty thing. A lot of binary. I got to look at it for a long time. I wanted to share it with all of you. It's a very fun thing to look at, very pretty, I know. So the binary is based on spatial locations. There were 8 occasions with 7 intervals. Now you may remember I said there were 7 stationary receivers. So how did I get 8 occasions? The first occasion, which is the initial, I guess, capture and mark, was the surgery date at the hatchery. So that's where every fish initially got its tag. So every fish gets a 1. They were captured and marked there for a mark recapture study. And then moving with the columns to the right, it goes downstream. So you have above Link River Dam, below Link River Dam, all the way down to the JC Boyle Reservoir stretch here. And like I said before, there were 3 release groups, or the 3 release locations, which are these columns here. Those were above Link River Dam, below Link River Dam, and above Keno Dam. So like I said, we wanted to spread the fish out to kind of maximize our capacity to have fish in all stretches of river, but we also wanted to try to guarantee, you can't really say guarantee fish be passing through the dams, but that's why we picked a release site above Link River Dam and above Keno Dam. We wanted to kind of maximize our odds that fish would come into contact with those dams to see if they were having effect on survival. And then with the actual analysis, I did a CJS survival model using program Mark. The detection probabilities were for each stationary site individually, and the survival estimates are for the intervals between the sites. So the survival between each stretch, making stretch specific survival. Also to do this, I had to set parameters for each release group because there were 3 release groups in 3 different locations. So for example, the fish released above Keno Dam, the sites upstream of there, those fish never passed by, so they would have 0 detection probability, but they had 100% survival up until that location because we drove them there in a boat and then dumped them there. So getting into some results, just starting out with total detections, not any fancy statistics yet, just the number of fish detected out of the total number that could have been detected. And as you can see, some of the percentages vary widely, such as Gore Island, only 22 of the possible 169 fish were detected there, Gore Island being this location here in this kind of middle stretch. But then other sites such as Miller Island, just upstream at this location, 105 of the 169 total fish had been detected. And something I really enjoy is that Spencer Creek, which is down here all the way in JC Boyle, just base number 71 of the 188 fish. So of fish released throughout the entire study were detected down in the JC Boyle Reservoir, meaning that some of the ones that were released in Upper Link made it, below Link River Dam made it, and Keno Dam made it. Now getting more into the statistical side of it through the program mark outputs. Yeah, the detection probabilities kind of vary a lot between sites. Some of them being as good as upwards of 95%, some of them being as low as about 16%. Something I noticed with this, so you could see these 3 lowest sites, the Upper Link River, Lower Link River, and Gore Island. Those 3 sites had the most interference of any of my stationary receivers. Gore Island, I was getting upwards of 200,000 data points a week of just pure interference. So those sites, when I was going through and filtering the data, I had to be very conservative with the filtering. I wanted to remove anything that could be a false positive. I didn't want to skew the survival estimates at all, so I had to be very, very strict with that filtering. So that's why detection probabilities were much, much lower, because I removed so much data from those data sets that it really dropped the detection probabilities on those. But even with relatively low detection probabilities, the survival estimates throughout the stretches are pretty solid. We have 94, almost 96, and then specifically with around the sections that have dams, so such as Upper Link River to Lower Link River and Upper Keno Dam to Lower Keno Dam, are above the 90 percentile. My eyes, pretty good, but it's all relative, I know. And the big question that came out of it for me was, what's going on between Lower Link River and Miller Island here? It's much lower than the rest, and I'll kind of touch on that here in a second. So once I got my initial results, some questions definitely came up. Are there ways to mitigate interference? Like I said, a lot of the sites had extremely high levels of interference, some of the sites being pretty much in downtown Klamath Falls, so there's a lot of noise going on, a lot of radio waves, radio signals that can be interfering with that. And so there was definitely some trial and error with the gain settings of the actual receivers trying to mitigate that interference. There can also be some issues with large water systems kind of pertaining to those gain settings. The signal distance versus precision with radio telemetry can kind of be a double-edged sword you walk. If you want to detect a fish 200 meters away in the water, okay, well, your precision for that's going to go down, and you're opening the door for a lot more interference to come in, because you're going to have to crank that gain setting up to be able to detect a fish at distance. But if you want to reduce that, you're reducing your distance that you can detect. So it's kind of, pick your poison a little bit. But like I said, the big question that came out of it for me is the lowest survival estimate in the Lake Yreka stretch. Lake Yreka being this location here. This is the outlet of Upper Klamath Lake with the Link River Dam. This is the Lake Yreka here, and then this upper section as a whole before my Miller Island site there, I was calling the Lake Yreka stretch. And for some reason, the lowest survival was there. And there were a couple ideas. There are large water diversions throughout this Upper Klamath Basin region, including the Lost River diversion, which is circled here. We don't know whether fish are going into the diversions or not. It was just kind of a question that came up being, well, there's a lot of water diversions. Are fish going off path? We just don't know at this point. Or is it predation? If anybody's been in the Upper Basin around springtime, you may have noticed the thousands of fish-eating birds that like to come through the area about that time of year. When I was releasing fish, there's probably about 100 pelicans and 100 cormorants just sitting on the bank looking at us, thinking we're bringing them a snack. I'm not big fans of them right now whenever I'm dropping fish in the water, but they're there. And we have some anecdotal evidence. We're finding some tags at bird colonies, and we should be finding out soon which fish those tags belong to. I'm hoping they're not mine, but it's very possible. So next steps, 2023. This season right now, I'm in my second field season for this project currently. I just released my third batch of fish yesterday. And this year we're doing our occasions based on temporal variation, not as much spatial. So we're doing multiple release dates, all from one location. So I want to look at the movement of these fish through time, not as much over space. We also added 3 stationary sites, 2 large water diversions on the river, including the Lost River Diversion Canal, the 80 Canal, and the North Canal, to see if fish are moving into these canals by accident and not staying in the main stem. Like I said, not sure as of now. I'm hoping to answer that question with these receivers. And then I'm also planning on including habitat covariates through times, so hopefully flow, water temperature, and dissolved oxygen. This graph shows the flow last year in Link River. So I released on April 12th, which is about right here. And as you can see, they did a flush flow right after I released my fish. That wasn't planned, that just kind of happened to be that way. But then it quickly dropped back down. Unfortunately, how my methodology was set up last year, there wasn't a way for me to incorporate flow into the model. So that's why we're trying to set it up as time-based this year to include flow as a covariate. And as of now, if anybody's been up there, they are releasing a ton of water out of the upper lake. So this should be really interesting when I get to that point. I'd like to thank all my lab mates for listening to the mass hysteria I've had about this project through the years. Thank you to all my collaborators for their funding, their support, their borrowed equipment they've given me. And then thank you to my advisor, Darren Ward, for giving me this opportunity and the opportunity to be here with you all, and all the help I've gotten over the last year and a half that I've been doing this. And I'll take questions.
Cool. Thanks, James.
Right there.
Great talk, James. My question is, do you know the average number of days it took a fish to move from receiver to receiver by any chance?
I don't, just because like it varied between receivers, some of them. So I can speak kind of anecdotally on a couple of them. Like currently right now, I released fish above Link River Dam, and within 36 hours, I was picking up fish in JC Boyle Reservoir. So they seem to move very quickly. That's something I want to look at, is timing for the specific reaches, like how quickly they move through specific reaches. But anecdotally, pretty fast, it seems like. I mean, 24 to 48 hours, and I'm picking fish up 40 kilometers downstream in JC Boyle Reservoir. And again, somewhat anecdotally, because it's just mobile tracking data so far, we found some past JC Boyle Reservoir. They somehow figured out a way to slip through, or maybe they got churned up and it's tags that wash downstream.
Yeah. One technical question.
Yes.
Have you or other studies looked at putting 2 receivers in, one setting the gain high, another setting the gain low, in order to get some of that distance, you know, and then, you know, the accurate for the short range, just to kind of clean up that interference? Is that an approach you can take?
I think it would be. I'm not sure what the interference between the 2 stations would be if they're on the same frequency. I could see them kind of
with each other.
Yeah, I know some studies have set them up pointing opposite directions, so you can track directional movement of fish.
Yeah.
I haven't found any projects doing the one high strength, one low strength. I'd be interested. If I had more equipment, I'd love to do that.
Yeah.
I was kind of limited. I picked my number of sites based on the amount of equipment I had.
You mentioned you used yearling Chinook. Can you tell me what size range those were?
I think the average was about 145 millimeters. So fingerling about yay big. We had some that were whales around 200, and some that were a little smaller in the 130 range. But they all averaged probably around that 140 to 160.
So you said you filtered the data and you had to get 3 detections because you didn't want to err on the high side, but couldn't you also introduce error, like erring on the low side, like rejecting legitimate detections, and what's the implications of that?
Yeah, so we did this methodology with our mobile tracking as well. We made sure we got 3 solid, basically pings or 3 solid detections to consider it a true detection. Because a lot of the time with these receivers too, you'll get a detection that has a tag number, but it'll just be a random interference wave. So that's kind of where we wanted to err more on the side of caution. If anything, I wanted to not skew the survival estimates high by leaving false positives in and making it seem better than it actually is. I'd rather be a little more conservative with the estimates. I spoke with my advisor about that as well, and he kind of leaned with me on that. He said, even if you get rid of some true detections, get rid of all of the false positives. That's more important in that sense.
What I was trying to get at is there maybe a way to quantify that?
Oh.
Actually, let's try to look at 2 and then see what the differences are. That way you might be able to start getting at quantifying.
Oh, yeah.
So you know you're erring on the low side. Right
Yeah.
now, but how much?
That's a good question. I'm gonna have to look into that. Thank you. Yeah, that's a great question. Now I'm gonna go home and do that.
Yeah. A question online from Jacob Kraus from USGS. How many fish were never detected after the initial release, kind of broken down by release site? So any of the 1000000.
Yeah.
How many of those did you have?
So I'm remembering this off the top of my head, so I apologize if I'm slightly off, but I think in total of 188 fish last year, there were 27 that were never detected. 19 from below Keno Dam, 19 from below Link River Dam, 1 from above Keno Dam, and 8 from above Link River Dam. If I did my math wrong there, I apologize. I'm a scientist, not a mathematician.
So a great presentation.
Thank you.
And something I may have missed is how far can you detect these fish?
So I did some field tests with the tags and a couple different depths of water. And we also took test tags out with us to the wide stretches of that upper basin, which can be upwards of 200 meters across. So I was individually setting gain for each receiver to minimize interference, but also get strong detections on the opposite end. So I was able to detect fish about 200 meters away in those wide sections, but that also opened it up for a lot of interference. Like that Gore Island site I mentioned, that was about 200 meters across, but a lot of interference there. So that was, again, kind of the trade-off. But I've done a decent amount of radio telemetry experience in the past, and it depends on the type of tag. Like I used to track rattlesnakes with radio telemetry, and you could pick them up from about 2 miles away if it was line of sight, depending on the tag. So these are very good on land, but then water can skew the detection as well. Of course.
All right. Well, James, thank you.
Of course.
Really cool.